super excited to be a part of the Roadster's billion-year journey through the solar system.
Now, as Lauren just mentioned, if all goes well today, Falcon Heavy will put the Roadster on board into an Earth-Mars orbit around the sun on a journey that could last for 1 billion years. Now, on a universal scale, this means that the Roadster will be tracing the shape of an ellipse with the sun at one of its fixed points, or one of its foci. Now, we call this heliocentric because it is sun-centered. The outermost distance on that same ellipse will intersect the path that Mars takes while it is on its own journey around the sun. That's quite far away. That will reach a maximum distance from Earth of over 400 million kilometers. In Earth terms, that's about the same as a trip around the equator 10,000 times. Now, during its journey, the Roadster will also reach a maximum velocity of nearly 40,000 kilometers per hour, or about 20 times faster than a speeding bullet. Now, as we said, it should stay up in orbit around the sun for about 1 billion years, and it's a very long, exciting road ahead, and we are thrilled to be able to take the first steps on that journey just 5 minutes from now.
The SpaceX team continues to count down for launch of Falcon Heavy test flight. Now, once we light the engines, Falcon Heavy will check the power on all 27 Merlin engines, a critical period in the go-no-go for launch. It'll then command release from the ground hold-downs. 40 seconds into flight, we'll decrease power on the 2 side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to full power on the side boosters. About half a minute later, we will again throttle down the 2 side boosters. This time we're decreasing the forces on the rocket structure. At this point in flight, the vehicle is much lighter, having burned off much of the propellant, but we are increasing thrust. 2.5 minutes into fully turn off the side boosters, an event called BECO, Booster Engine Cutoff. At this point, the pneumatic separation system on the center core will unlock the 2 side boosters and push them away. The side boosters will disconnect first at the top of the center core, then milliseconds later from the bottom, so they'll actually rotate away from the center core slightly. Once the side boosters are clear, the center core will throttle up to full power and burn for another 25 seconds. Finally, at just past 3 minutes after liftoff, the center core will shut down, an event called MECO, Main Engine Cutoff, and the second stage will separate. From this point on, it's like a Falcon 9 mission. The fairing will separate, the MVAC-D upper stage engine fires, eventually sending the stage